Task 3 of the Relocation Destinations in Amphibious Cities by Walter and I. So coastal cities are at threat from sea level rising and polar reversals. Our goal is to create a more resilient future for residents by preparing and planning for these catastrophic events that are to come. We are building amphibious cities for people to be able to sustainably live on the water, and we plan to create well-rounded closed-loop amphibious cities that are 100% functional and livable. So for our site, we chose Huron Lake in New Mexico. This diagram here shows the exact location of the lake in Arapahoe County. Go to the next slide. We chose this location based on our site analysis. Lake Huron is approximately 2 by 2.5 miles, and there is about 35 miles of shoreline. The lake can hold about 400,000 acre-feet of water and is up to 200 feet deep at the deepest point of the lake. So we thought this lake would be pretty suitable for our prototypes. So now we move on to our master plan of both the prototype and Lake Huron, the prototypes on it. A city that is ultimately very well-rounded and has different features which make up the city as a whole. The prototype itself would be a very green system with green walls and green roofs along with crimson air, water plane transportation, and much more that we will dig into deeper in the later slides. And then to the left, you can see an axon diagram of the prototype itself, showing many of the different components and the features of it. They include, but are not limited to, solar panel glass domes surrounding the prototype, evacuation space shuttles, skyscrapers and living quarters, elevated walks, helicopter landing pads, and much more. Go to the next slide. So this diagram here is to show the capacity of our prototype, and it breaks it down to the different parts of the city, from neighborhood, which would hold about 2,000 people, to the village, which can hold 16,000, all the way to the city, which is the whole lake, holding up to 50,000 people. And so then this diagram shows our planned phases for the relocation destination. Phase 1 would be building the prototypes. Phase 2 would be to choose the locations that are suitable for the prototypes. And then phase 3 would be placing the prototypes to their adequate locations. And then here is a section of the 3 prototypes placed onto Huron Lake. It is showing some of the different features we talked about just in a section view. So we will look deeper into the sections of the prototype itself and the functionality of it in the next slides.
So moving on, this is like prototype composition and how like everything is coming together. Pretty much like Ashley was saying, was like a dome that you not only capture the sunlight, but it also protection. Also like ventilation fans, like to ventilate the air coming in and out of the prototype, and also the turbines, to move the prototype from one place to another. We have transportation, hydroponic farming, the buildings, for multi-use, and for education, for jobs, and for housing as well. And also some vegetation at the core of the prototype. And also we have some green roof at the top, just to help like protect from the solar radiation. So breaking into sections, and when it comes to energy, this is kind of just an example of the current condition. I mean, this information was from 2016, and all the type of energies that the United States is currently consuming. And we break out in like different sections and that are currently using. The most high is the transportation and the electricity generation. So when it comes to the prototype, one of the main, I guess, energy producers is going to be the glass that is going to catch the energy and transform it into, the sunlight transform it into energy. And then the other one is going to be the OTEC system, which is going to transform the ocean water into energy as well. And this is kind of like plant-based food component. This is the hydroponic farming and how it's going to look like in the inside by the different features they're going to have, like light sources, heavy, easy harvesting, and water tube, as well as computer monitoring daily, just to come up with a good product. And this is gonna be like the function of the, I guess, the central part of the green infrastructure, and how the plants, along with the humans, they're gonna coexist together and make a livable place. And this is the soil role as well within the prototype, how that's gonna capture the carbon sequestration and also the composting mixed with the soil. And the different type of transportation that we're planning to use. The pretty much the first one, I guess, is walking. The second one is delivery drums that make it possible to transport from one building to the other inside the building. Passenger submersible, flying taxis, and hydrofoil water taxis. And this is lastly, this is the energy use diagram. This is on this side right here, we have the current condition of the waste that the United States is producing currently. Like, as you can see, 80 billion pounds of food is thrown away, and that is about 1,600 per family each year. So we want to reduce that amount, like about 70% of New York City average per capita, implementing all these strategies that you can see in this diagram, like the compost fertilizer plant, algae filtration, anaerobic system, exchange hubs, collection system, and hydroponic system that are linked towards the core, that is going to be breakout into organic waste, sewage, and recyclable.
And then here are just some perspectives from inside the prototype to kind of give you a feel of what it would look like on the inside.
All right, thank you. Is Reese ready? Reese, are